Today we wanted to follow up on our previous webinar on talk through a couple of examples. So we have been very lucky to have been able to reach out to South Pole, who are a global consultancy and advisory firm working in this space, and who have graciously offered to talk us through a little bit through some examples of scenario analysis and give you a bit more background. So thank you so much. We have a very international panelists today. We have people from the UK, from Switzerland, and from Mexico, I believe. Hopefully we'll get some international perspectives. With that, I'd like to hand over to South Pole, please. Thank you very much.
Great. Thank you, Mike. Welcome, everyone, to this TCFD Scenario Building and Use webinar. It's come about really because, we understand that, you've had an introduction to scenario building, but of all the TCFD elements, it seems to be the one that's, attracting most interest because it's so new, it's so stretching and so far-reaching. So we're delighted to be invited to share a bit of our experience and knowledge on this, fast-moving and growing subject. So South Pole, we're a consultancy. We're global. We work with corporates. So we're penguins, as we call ourselves, spread across 18 offices globally. I'm the head of the Corporate Risks and Opportunities Division based out of London. And I'm going to be facilitator for today. And I'm joined by Charlie Brunel-Lister, who specialises in transition risk modelling, and Dr. Nico Kroner, who's an expert in climate modelling. He's got a PhD in it. They're your expert panel today, so you're mainly going to be hearing from them. What we have is just a little introduction from me, setting the scene, and then we're going to run you through 3 steps for scenario analysis. We're going to run through a couple of case studies of scenarios that we've found or we've worked on that we really like, or maybe we don't like so much, sort of analyse them. So our main objectives, as you will read there, is to help understand what scenarios are, to guide through these practical steps, and to highlight best approaches. But I thought at this point it might be worth just refreshing our minds on what a climate scenario is. A climate scenario, it describes how the future may evolve, considering variables like greenhouse gas emissions, GDP, technology, energy, land use change. And it's really aiming to better understand uncertainties in order to inform decisions that are robust, they're based on some sort of evidence under a wide range of possible futures. And they also provide data for a model to then go forward and calculate in more detail what the implications are. Just a quick word also on 2 degrees, because we've been hearing a lot about that. 2 degrees pathway is kind of the baseline scenario that's being recommended under TCFD, and it's particularly important because it pegs against the intended outcomes of the Paris Agreement, and it's really the upper limit of what's deemed to be scientifically well acceptable, or what's going to limit the worst effects of climate change. So it's also the level that businesses are signing up to, or the sort of maximum level under the science-based targets. So the format of today, I'm going to do this very quick introduction, then I'm going to hand over to Nico and Charlie, and they're going to be talking sort of together or in sort of stages. Then we'll talk about these case studies and then these Q&As. So why scenario analysis? Why is it important? So smart businesses are using it to prepare for this carbon-constrained world that we're already feeling, and also the physical risks of climate change that we're also experiencing. And they help meet demands for better management and disclosure of climate risks, both for TCFD reporting. I know businesses are already committed to disclosing climate risks in mainstream filings for TCFD, including this 2-degree scenario. And there are already pushes, or there's mutterings about mandatory disclosure. So the quicker that businesses get to grips with scenario development, the more they will gain competitive advantage. But also, as I'm sure many of you know, CDP is also streamlining itself and aligning itself with TCFD. So there are already questions in this year's CDP report and over 800 institutional investors are requesting disclosure on GHG emissions, energy and climate through CDP framework. And science-based targets are also being integrated into the scoring system. There's also other reporting frameworks such as Article 173, Climate Action 100, that are also encouraging reporting of climate risks and scenarios, and it's very likely there'll be more to come in the future. So just to set the framework of within which scenarios play out, there's, on the right-hand side, you will see, a sort of an aggressive mitigation strategy globally, and that could be like a 1.5 degree pathway, and that implies transition risks, i.e. risks from a decarbonized economy, such as carbon pricing, legislation, reputation, market shifts. Whereas on the left-hand side, you've got so-called business as usual, emissions as usual, and that's where the physical risks manifest. And you're sort of facing global warming averages of 4 degrees or above. Whichever pathway we end up on globally, there will be a blend of these physical and transition risks, and that's what scenarios aim to explore for individual businesses. And scenarios help make sense of both these extremes, these sort of bookends, if you like, and then the possible blends in the middle, in between. Here's an example of some risks that an agricultural business might face, whereas at the lower scale, lower end of warming, you have switches in societal shifts towards localism, organic production. You have policy and legal shifts. You have carbon pricing, for example, at 75 euros a ton. Whereas if you don't have these mitigation measures put in place in these instruments through governments and institutions, you're looking at a more physical risk, such as imports from Africa suffering damage from migration, further migration shifts. Insect-derived additives might be more commonplace. I mean, these are just hypothetical examples, but it shows that there's a huge number of ways that physical and climate and transition risks might play out, and this just gives a little snapshot example. So what I'm going to do now is hand over to Nico and Charlie, and they're going to talk you through really the A to Z of scenario analysis and scenario development. So the detail and the ins and outs of establishing a scenario, how you go about choosing one, whatever your starting point. So Nico, over to you.
Thank you, Joe. Hello from Zurich. So my name is Nico Kröner, as Charles already introduced me, and I'm presenting you together with Charlie now, who's sitting in Mexico. And the first thing we want to do is to give you a small overview of the 3 steps needed to do a scenario analysis, which is scenario selection, the risk analysis itself, and reporting and disclosure. And step 1 is divided into 3 tasks, which are defining the operational boundaries, then choosing the relevant risks and the relevant scenarios. Due to the different nature of transitional and physical risks, task 2 and 3 are divided or separated between physical and transitional risks, with Charlie will present you how to do that for transitional risks, and myself will present how to do it for the physical risks. Step 2, the risk analysis, will be mainly talking about how to define the right indicators, how to find the right metrics and data sets to really perform this risk analysis. And then in step 3, we will briefly touch on reporting and disclosure issues. In general, this looks a bit linear now, but of course, this is not really a total linear process. But things you learn during the risk analysis will later feed back into scenario selection, so maybe improve or choose different scenarios. And with that, I would like to jump into the first step, which is defining an operational boundary. This is the same for physical and transition risks, and this is really a very important step, because here you make sure that the scenario analysis is really fit for your purpose, that you don't get results that you in the end maybe doesn't need or doesn't make sense. And there are different things you have to take care of. One thing is the geography, so where do I want to do my analysis? And then, of course, there are things like the order of effects or the scope, which are a bit related to each other. In this respect, you have to see, do I only look at first order effects? So, for example, do I only look at hurricanes really hitting my facility? Or do I look also into further away from my company, like upstream risks, like a second order effect would be how are my supply chains interrupted by certain events? And of course, also looking more downstream into maybe market risks. So how will my customers change, my customer bases change in maybe regard to new carbon prices, etc. And then last thing you kind of need to look at is the time frame. So of course the time frame is also something important. So how far do I go into the future, and what do I want to learn there? And then these things are all kind of interrelated. So for transition risk, it's good to go as far as possible, but also not to go too far and in the first attempt try too much, which then maybe can be also overwhelming. And with that, I hand over to Charlie, who will start with the transition risks.
Thank you very much, Nico. I will now focus specifically on transition risk selection. So the process splits up after part A. We have designed a very simple way of screening risks, which is basically it's made of 3 steps. One should be collection, as much risks as can be found. Then the classification of those risks based on materiality, and then the selection, which will be based on the materiality, but also on feasibility and your budget. So the areas of work that we have been selecting for this are like collective work. This should be done with ERM, CSR, the C-suite, and you should also perform a literature review and analyze existing scenarios. But then, what are the scenarios that you should discriminate? I will first start to present the IEA scenarios that most of you maybe already have heard of. So the IEA is split up in 2 different publications. One is called the World Energy Outlook, and the other one, the ETP. The first one is the oldest one, and in the new version for 2017, it features basically 3 main scenarios. The most progressive being the Sustainable Development Scenario, which aims at achieving the 3 SDG-related scenarios. But that also features like all scenarios, like the 450, which used to be used a lot by oil and gas companies for scenario modeling. And then the ETP, which is much more progressive and has like much more decarbonated world scenarios. But apart from the IEA scenarios, which are the most widely used, you also have, for instance, here I presented 3 different scenarios: the Greenpeace Energy Revolution, the DDPs, and the IRENA, which is the equivalent of the IEA, but for renewable energies, which have all created their scenarios for a 2-degree world that are slightly different from the IEA, but that are much less widely used by companies. And there's also the SSPs, which is a very integrated scenarios that allows for physical and transition risks analysis at the same time. So then, how should you choose in between all those scenarios? How should you discriminate? First, you should decide whether you should have a public, a corporate, or a hybrid scenario. Hybrid being a public scenario that has been built up with literature review. In our sense, the hybrid scenarios tends to be better because it combines the advantages of both public and corporate scenarios, and it allows for comparability, but at the same time being very adequate. Also, you should always have 1 2-degree scenario, and you should always start with qualitative information and then become more quantitative over time. You should integrate the scenario analysis to your ERM processes, and also always disclose very clearly what is your approach to your scenario, what are the inputs that you have, your assumptions and your analytical methods. And so this this is presenting basically all the scenarios that have been talked about that are presented by the TCFD and the risks that are related. So you basically see that legal, market, and reputation risks are not within the scenarios, and it's a problem because the TCFD is asking you to assess them. So this is why you need to do a literature review and create your own assumptions. I will now hand over to Nico for the physical side.
Okay, thank you, Charlie. And with that, I start further with the physical risks. So now we are back at task B, which is choosing the right risk category or built-in risk inventory. And normally what is important, as also for transition risk, is to find materiality. And here, the first step is to analyze historical impacts. So from historical impacts, you can see which kind of risks and hazards, for example, heat waves or thunderstorms, are impacting your business and how strong it is, which gives you already an idea about the vulnerability you have to different kind of physical risks. But it's not only these kind of extreme events, it's also important to see if your business is, for example, very related to seasonality. So because with climate change, there will be shifts in seasonality, and if you're depending on if your kind of revenue has a seasonal cycle, you should also look at these things to understand them better. If there is no data within the company available, then there's always the possibility to start from a more general assessment, which is shown in this table, where you have different risks and the kind of impact they have on different sectors. And from there, then you could kind of drill down to your specific business and say, okay, these risks are really the one I want to look at and to analyze. Which scenarios are there to do this analysis? There are 2. It's the RCP scenario and also the temperature change scenarios. Now you just see the RCP scenarios. And on the left, what is RCP? It's the representative concentration pathways, which simulate how the energy budget in the atmosphere will change, and then you can translate that into temperature change. And then there are 4 different ones, with the RCP 2.6 being the green one, the lowest one, with a very high mitigation, so not too much more greenhouse gas emissions, and we limit temperature to 1 degree, or RCP 8.5, where we really go to high temperature changes end of the century. The temperature change scenarios are in kind of a similar way. They just, instead of using time as independent variable, you use temperature as independent variable. So you can see in the graph on the left side that a 2-degree temperature scenario can be reached by 2 different RCP scenarios, by the RCP 8.5 and also the RCP 6, just in different points of time. But if you don't care about time, then you can use kind of more information to build your 2-degree scenario. How should you select such a scenario? And here, the most important parameter is time. So if you are just interested in the next 5 years, it makes no sense to really go into scenario analysis. Then it's better to just stay with the historical analysis and do a probabilistic look probabilistically at the trends you already see in weather patterns and analyze them for the selected risk inventory. If you want to go kind of the next 5 to 20 years, then model data is already important, but you see again, the scenario doesn't really play a big role. So they are almost the same temperature changes predicted by the different scenarios. So here it's again more like a probabilistic analysis. And only if you really go to like far into the future, more than 20 years, then you again rely on model data, but then you also need to do scenario analysis, which means you look at the different scenarios, different RCP scenarios to get an idea on the different risks in the future. The second important decision one has to take is the granularity of the data. So what granularity do I need to do my analysis? And there you have kind of 3 different options, which is a kind of a low granularity, meaning you're just looking at the global climate models, which means they have a resolution of 100 by 100 kilometers. So you just get an indication of what is happening in the future over your in a country or over your facility. Then if you need a bit more concrete information, more granular information, you can go to kind of a medium option, which be regional models. They downscale global models and give you a resolution of 25 kilometers. And with that, you have better information if you need these high granularity to do a more specific assessment. And the last option would be to go for really high granularity, which then means you go for a statistical downscaling. There often the problem is that depending on the geography you have chosen, there is not such a data set available, or the data set is not available for the specific risk you are looking at, and then you may have to do the statistical downscaling yourself. And with that, you kind of getting these different decisions. If you do them, then you can kind of choose which scenario you would select. So you can choose between the representation concentration pathways or the temperature change scenarios, depending on if time is an important parameter for your scenario analysis. And then you really have to decide which is the much bigger decision on the data set. So which resolution is important and which risk do I look at and which data set can I use there. And with that, I hand back to Charlie and an overview over what we said so far.
Thank you, Nico. To sum up all the scenario analysis that has been presented for step 1, we differentiate between 3 categories of scenario analysis: newcomer, intermediate, and advanced. So if you're a newcomer, it's maybe the first time you're doing scenario analysis, you should focus more on having an IEA 2-degree scenario and 1 or 2 scenarios of the IPCC, and only focus on like maybe 1, 2, 3 major risks with low resolution data and no quantitative data. And over the years, while you become better at doing this, you will become intermediate or advanced. And in the case of advanced, you will probably use the SSP scenarios because they provide you with good sensitivity. And you would probably use also the 4 IPCC scenarios, and maybe even do scenario analysis against your SBTs. Thank you, Nico.
Thank you, Charlie. And we are moving to step 2 now, the risk analysis itself. And here again, I will show you a brief overview of what steps there are you have to do. It's kind of again three tasks which there are. First one is define a risk indicator. This one really depends on which risk category and scenario you have chosen before, and then you need to define an indicator which is fit for the purpose in terms of time and intensity. So for example, a heat wave you can measure in lots of different ways, and depending on your business and on the impact it has on your business, you need to get a different indicator for the different risks. Then you look at collect the data, and then normally you often go with a typical insurance way of looking at it, but you say you have an exposure, vulnerability, and a hazard, and you have to fill these three things with data. meaning the exposure, which is mostly internal data. Where are your facilities? Where is the things which are most critical for your business? Then the vulnerability, which can be deduced from the historical analysis, but maybe you can also use external data to get a feeling of the vulnerability within the company. And last step is the hazard. This should kind of be defined already by the scenario and the risk category, and then it's just about collecting the data. And last but not least, collecting the impact. So you kind of overlay now the three steps, the exposure, vulnerability, and hazard, to calculate a risk. And if the data quality is good enough, you can even do an uncertainty analysis and move it further to financial applications or financial implications. To give you an example how this in general could look like, I will move further and show you some examples from the transition and the physical risk side. So what you can see here is the general risk categories, and then later you can see the metrics, the models, and which data are used to assess those risks. So for transition risk example, there is the policy risks, and then you use metrics, which can be a carbon price, and the models give you the carbon price or investigations about how the carbon price will develop over the next years. And data can be the different scenarios from the World Bank, OECD, or also the SSP. And then same for the physical risk. You again define a metric, look for the right models, and then get the data to do your analysis. Don't want to spend too much time on this table, but jump right into an example. So this would be a carbon price example, which means, okay, you really find, that's now for the current day, you find where are certain trading schemes in place, certain carbon taxes in place, and you overlay that against your facilities and your areas of operation to see where are your carbon intensive areas, and do they are in risk to become carbon priced in the near future, for example. And with that, you already get a heat map on the risk of the policy risk getting a high carbon price. And the next example comes more from the water stress side. So it's a physical risk example, and here we are looking from a public data source, which is the aqueduct tool, and with that you can integrate it with the knowledge of where the facilities are and how big the water consumption is. So the water consumption of every facility in this graph corresponds to the size of the dot, and the shading shows the water stress, future water stress in this region, which gives you a kind of easy overview. Where are the hotspots? Where do I need to look closer? Where do I have to maybe develop adaptation measures to deal with the future water stress? And with these two examples, I will already close the risk analysis because there will later also come some case studies. So don't want to spend too much time here, but give Charles the possibility to talk a bit about future opportunities also.
Thanks, Nico. Yeah, I mean, as we all know, TCFD, very much highlights the opportunities from climate change as well. And really, this is the reverse side of the coin from the risks. Businesses that are anticipating and dealing with risks ahead of time are seizing the opportunities from the low carbon transition. So the way that we tackle this question of opportunities is we look at the different options, and we consider sizes of markets and trends for clean technology, for example. And that could include a number of categories such as resource efficiency. That would apply to pretty much every business. Renewable energy, again, would apply to every business. And most businesses are manufacturing. There are opportunities for new clean tech solutions to potentially replace their existing manufacturing streams. But think back to Nico's map of existing and future carbon prices and emissions trading schemes. That would apply to any business that has supply chains in any part, particularly complex supply chains around the world. And those businesses that are reducing the carbon impact of their supply chains are ultimately seizing the opportunities from reducing the risk of those carbon prices and potentially getting competitive advantage. There's also the potential for green finance, such as green bonds, and attracting finance for innovative financial mechanisms and instruments for sustainable infrastructure, for example, and then also securing supply chains and securing supply by adapting to climate change, making sure that there aren't water stresses to commodities and particularly in agriculture and forestry, for example. Data sources that might be used for that are market analysis. Trade associations are increasingly looking into this field. The media, clean tech, news feeds, and patent databases. There are, for example, an AI learning patent database that we've tapped into that will allow you to search whatever your technology sector, will allow you to search and find where the patents are being lodged in which geography and at what time frames, and that can give you an idea of trends and growing interest in certain clean tech solutions. So then we move on to the question of reporting and disclosure. And I don't want to dwell too long on this, but of course TCFD is encouraging full disclosure ultimately of climate change risks and opportunities for every business to better inform investors so they can make better informed decisions by judging one business against another. But in the early years of TCFD, it is recognised there is a risk to disclosing fully. So, we would encourage that as the ultimate goal, but initially the filings that we've seen are more qualitative in nature. So, that is the approach we would recommend until there are tried and tested techniques for, quantifying risks. And certain trade associations and industry sectors have already come up with more quantitative methods. But, and these elements could include description of climate-related risk where they're identified, so just in the initial stages, a listing of what these risks are, including the approaches used, the methodologies, a description of the scenarios used in the analysis, and then conclusions on the resilience to climate change against those risks. Take this with a slight note of caution, how far to go with disclosure initially, but ultimately, prepare for full transparency in the next 3 to 5 years.
Okay, so then we move over to case studies and give the floor back to Charlie and present the first case study.
So I will now start the case study for corporate. We've selected the company from the electric and gas utilities sector, which is AGL Energy. They are basically the largest corporate emitter of Scope 1 emissions in Australia, with around 44 million tons emitted in 2016. So after the Paris Agreement, they've decided to create their own scenarios to see how they could align with a 2-degree warmer world. And you have here an overview of how they did that. So they did both hybrid and corporate scenarios. They used 3 different scenarios with different time horizons for 2 different transition risks, no physical risks, but with a financial impact. So here are the 3 different scenarios that they've been using. One is a business as usual scenario. The other one is an INDC for Australia, and the other one is a 2-degree warmer world. And the 2-degree warmer world is based on the carbon budget from the IPCC AR5. So with those scenarios, they end up with 2 different energy mixes, both of them having a strong share of coal. And for the policy, so this is about the technology risk. And we don't know exactly, but they don't explain exactly how they do it, but basically they use this energy mix to transfer it to NPV for them. So maybe they exactly reflect this energy mix into their own energy mix. And for the policy risks, they're also not really detailing what they do about it, but to just say that under $100 a ton for carbon, it wouldn't be the price wouldn't be high enough to close coal power plants. So this is very interesting because they did an NPV. You have the detail in their reports of the calculation, but basically what you need to focus on is that they think that in a 2-degree world, they would lose only 25% of their value, of their economic value. And this is not even sure because this would be in the worst case policy scenario according to them, which is the light blue section you can see here. So in conclusion, we can see that there are some advantages and some drawbacks to this scenario analysis. So the main point is that they did some financial impact modeling, which is a very rare thing. They did it also a long time ago, like even before the TCFD was published. But they also have a lot of drawbacks, such as the fact that they did not do a physical risk analysis. And the main point is that it's something that you should very consider is that it is potentially biased. Why is that? It's because of the fact that they are one of the main coal electricity producer, and their website, for instance, is only talking about renewable energy, while they are one of the main producer of coal electricity, and they don't think that the risk is higher than 25% of loss. So we can ask the question: is the report biased or is it greenwashing? And yeah, this is something that you should consider when doing your scenario analysis. Don't underestimate the risks that you're facing. I will now hand over to Nico.
Thank you, Charlie. The second case study comes from the finance sector. This time it's anonymous. A screening done by South Pole from us. So the screening is an investment portfolio, and the screening was related to physical climate risks. So in the end, what in the same sense as before, it was a scenario analysis. The scenarios used were public. It was 7 different scenarios, 3 RCP and 4 temperature change scenarios. And the time horizon was kind of starting from near future to the end of the century. The transition risks were not assessed in this case study, only physical risks. And here is one of the important parts, as said before. The risk category is an important thing you have to choose when doing a physical risks analysis. And here it was chosen that to be comparable against different holdings, different portfolios, different sectors and industries, the physical risk category should be an aggregated measure. So getting all the different physical risks to one measure so that you can really compare it between all the different sectors and not getting mixed up with having a heat index, heavy precipitation index, and so forth. Financial impact was not considered, although the risk score is designed in such a way that it gives an indicator of an indication of possible financial impact. How does the analysis look like in the end? What you can do, for example, you can show a geography. So unfortunately, we cannot show you the real portfolio, but it's just now an index. But nevertheless, you can find where the geographical hotspots on the risk exposure are. So for example, for this index, it's strongly the US, you can see, because this is heavily invested in the US, but also countries which were less invested in but have a higher risk profile, like Brazil or China or India are popping up in this analysis. So this is done for a 4-degree scenario where you can see the contribution to the risk from different geographies where the investment portfolio is invested in. Beside that, you can also look at it in a way for different sectors, where you can see the risk contribution for different sectors coming. Yeah, this is now for the gig sectors, but you are free to choose which sector or classification is the most valuable to you. Further, you can use this kind of sector analysis to compare different sectors, see which sector you are invested in is really one where such a high exposure, you have a high risk score, and you could think of reducing or changing the holdings within the sector. And this brings me to the typical topic of a benchmark analysis. So what you see in this graph is on the risk score or change in economic output on the y-axis, and then the time on the x-axis. And you can see in blue the analysis done for a high mitigation scenario. That means almost no temperature change. On the 1 degree, and you can see the risk is not really high for none of these portfolios. What you can see, the different in the color is the scenario, and the different dots or the line is different portfolios with a high risk normal portfolio and a low risk portfolio. And then if you would go for business as usual, which means RCP 8.5, so we really come to high temperature changes in the future, you can see how the high risk portfolio really scores much worse than the other two portfolios. And with that, you can also kind of compare your portfolio against other indexes, other portfolios to see how you are doing in the benchmark analysis. And with that, I already closed this.
Thank you very much. I'd like to thank Charles, Nico, and Charlie. Thank you. This was a really insightful presentation.